Welcome to the Hydrates lab. In this lab, you guys are going to take two different salts and you're going to prove ratios of the ionic compound to water. All right, so you got to understand what a hydrate is. A hydrate is a hygroscopic compound. It means that it absorbs water from the air. And the cool thing about it is that hydrates always absorb a specific amount of water molecules from the air for every single formula unit of the ionic compound, right? So you can see the copper 2 sulfate here absorbs 5 water molecules. The zinc sulfate absorbs 7 molecules. That dot that you see is defined up here at the top of the screen, if you can see my mouse. The dot at the top, it's a simple multiplier. All it does is multiply the number of water molecules that are absorbed for every formula unit of the ionic salt. Your job today is to take these salts that have water absorbed into them and heat them up. And when they heat up, the water molecules will evaporate. They'll leave and go to the air, and we'll have dry salts left behind. This is what we'll have left behind when we dry them out. And so when they're dried out, they're called anhydrous. When they're wet, they're hydrates. When they're dried out, they're called anhydrous. We can measure that weight difference and then prove the ratio of dry salt to water. All right, I'm going to show you how to do that today. So here are your two hydrate salts. They already have water absorbed into them. Here's your copper 2 sulfate. This is not the zinc sulfate. This is Epsom salt. And Epsom salt is used, sometimes people will dilute it and drink it because it acts like a laxative. Sometimes you might take a bath in it because it's a mild muscle relaxant. And so it is magnesium sulfate heptahydrate. This is our copper sulfate or copper 2 sulfate pentahydrate. You can tell it's penta because of the 5 waters right there. This is your evaporating dish, and this evaporating dish is made out of porcelain, and porcelain is porous. So there's water trapped, water vapor is trapped inside the porcelain, making this heavier. We need to heat it up so that we can evaporate all the water before we weigh this thing. And so you're gonna have your creme brulee letter, and you've got your Bunsen burner. Go ahead and fire it up and make a nice single blue flame. If you've got a double flame, if you can see there's a double layer right there, you just close your carburetor righty-tighty until you see some yellow flame, and then open it back up again until all the yellow goes away. Remember, no yellow flames because the yellow flames leave carbon or soot all over the lab gear. So make sure you've got a nice, cool, single blue flame. To start out, this empty evaporating dish is going to be nice and cool to the touch, so you can just simply place it over your single blue flame and leave it there for as long as it says in the lab. And that's going to evaporate the water from the evaporating dish. To get it out of there, you're going to want to use crucible tongs, and today they're going to be evaporating dish tongs. Let me model for you how to do it. You want to grab the edge of the evaporating dish and don't squeeze too hard. If you squeeze too hard, some of these crucible tongs will overlap like that, and when they overlap, they'll drop whatever they're carrying. So nice and gently grab the edge, and you can set it on your bench top. Before you weigh your evaporating dish, you want to make sure that you've got your cardboard in place on your scale, and the cardboard is going to protect the scale from being burned by the hot evaporating dish, which you're letting cool down now. You got to let it cool down for as long as it says in the lab, so that you don't actually ignite the cardboard. So you put the cardboard on there, press your 0 button, 0 it with the cardboard on there, and then bring your evaporating dish over, set it on the cardboard. Put your hands over because the vents will be on, blowing air everywhere, and get a good mass for your evaporating dish. It's going to be bouncing all over the place because it's probably even like taking on more water. So just let it calm down and write your mass down for your evaporating dish, not this mass. That's why I'm going to stop doing that right now. Your next step is to find about 2 grams of each of your hydrate salts. And so you've got a weigh boat and you've got your 2 salts. Be careful, notice we're using Slurpee, plastic Slurpee spoons for the copper salt, and the magnesium salt we're using stainless. And that's because of the metal activity series. You just did the metal activity series lab. The materials in stainless steel are less reactive than the magnesium in here, so we won't get corrosion on the scupula here. But the copper sits lower, or is less reactive than some of the stuff in the scupula, so we can't use the stainless scupula in the copper, or it will corrode it. For that same reason, we can't leave any copper on the stainless of the scale, or will corrode that as well. That's probably why you see corrosion on it already. All right, put your hand over your heart, repeat after me. I promise not to put the stainless scupula in the copper. All right, that was perfect, thank you. The next thing, right, is to 0 the scale with your empty weigh boat on there and add 2 grams of salt. Don't obsess. I kind of did. You can get within, if you get within 0.05 of a gram, you're good to go. And once the number stabilizes, you can put your hand over it, let it stabilize, and write that number down for your mass. Here we are again, back at our Bunsen burner. I've got my safety ring, I've got my empty evaporating dish, and I'm going to take my 2 grams of the Epsom salts, or the magnesium sulfate hydrate, and make sure those all make it back in there, and then place it on the screen. And so, okay, as the water is driven off of this salt, let's see if I can change the settings a little bit. There, that looks good. As the water is driven off of this salt, when I say driven off, I mean as the water evaporates, it's going to go through some phases. The Epsom salt is going to get sticky, it's going to get gooey, and then it's going to be dry. And I can see right now that can you see the sizzling and the bubbling in there? That's the water. And if it starts to pop, you take your Bunsen burner and you move it away. You just move it away, you let it cool down a little bit, and then you put your Bunsen burner back, you continue to heat it. If you overheat it and it starts to pop, you're gonna lose some mass. The mass is gonna end up on the floor or on your bench top, and then your percent error is gonna be really bad. And so keep trying it, keep moving the Bunsen burner back and forth, on and off of it so you don't pop. Right now, mine's getting really sticky and really gooey, and when the water is all evaporated from the hydrate, you are going to see a nice white fluffy powder. I've turned my Bunsen burner down even more, and I'm just stirring around, holding it with my crucible tongs so I can apply some force here to the Epsom salt. I like how this is turning out because I'm not losing any. I don't hear any popping because my single cool blue flame is seems like it's just the right temperature, and I keep moving it around, and notice that my stir rod has some salt on it, And I don't want to lose that mass. So I'm going to try to just wipe that off with my finger and get as many of those formula units of the magnesium salt back in there. Now we're looking at an anhydrous, or a dry magnesium sulfate. That's ready to weigh. Now you're going to do that process again with the cardboard, because your evaporating dish is hot, and you zero it, and you've waited a couple minutes for your evaporating dish to cool down. If it's too hot, when you place it on the cardboard will ignite. It'll just burst into flames, or it'll smolder. And so wait for it to cool. I'm not actually setting mine down right now because I haven't waited long enough. So you'd set yours down, get the mass of the evaporating dish and the salt. Of course, subtract the mass of the evaporating dish afterwards, and you've got the mass of the salt. Well, like Dr. Moody likes to say, I hope you're not blue and white challenged. So here's where the blue salt goes, and that's why the paper is blue. There's none in there right now, so it's hard to tell you, or hard to show you. And over here, this is where the white salt is gonna go. The white salt is the magnesium salt. Don't mix the salts. We can easily reuse these salts next year, and as we let them sit around, and water from the atmosphere rehydrates them. Your last cleanup step is to clean this thing with hot water. So I've dumped out my white magnesium salts in the white beaker for waste, and it's cool to the touch, but these things will expand and contract with changing temperature. And if the expansion and contraction is faster on the outside than on the inside, or slower on the outside than the inside, then it'll tear the bonds apart, and that's what a crack is. It'll break and shatter. So get this water as hot as you can. It'll be about 50 Celsius, and rinse it out with your hands. Wash your hands, dry it with some paper towel, and then go back for your second salt. Your second salt again, it's going to require all the steps again. You've got to dry this thing out with your Bunsen burner for a couple minutes, and then just repeat everything. All right, good luck, everybody. Have a great lab.